So to start the trigonometry portion of this course, we first need to talk about angles. So before we can explain what an angle is, we have to talk about what a ray is. So a ray, is when you have an end point and then it's going off in one direction. So you might label the end point A, and then they usually will put another point somewhere on the ray for labeling purposes. And so you could say that is ray AB. Or you could write it in notation like that. So that would be ray AB. Okay? So you have one end point, and then you have a line kind of just going one way. All right? And that would be a ray. So an angle is when you have two rays, so a ray and maybe another ray, and they have the same end point. Okay? So you could call that angle A. The angle is this right here. Sometimes they'll give it a number like 1, or sometimes they will put more points on the rays, and so they might label that angle, and then that's the symbol for angle, BAC. That would be one way you could label it. Okay? And so that's what an angle is. You're talking about the distance then from one ray to the other, I guess. Okay. So we use a lot of Greek letters in geometry and science and in trigonometry. And so they want us to be familiar at least with some of the Greek letters. So theta is like this. It's one of the ones we use the most, I would say. And then this next one, it's pronounced phi, but I hear it all the time pronounced phi. So I think in the math and science world we say phi, and everybody else says phi, but I could be wrong on that. But phi looks like this, or they'll also do it like that, kind of. Usually when we're writing in math, we kind of want to be quick, and so we do something like that. Alpha, kind of like that. Beta, and then gamma. So a lot of times they'll use alpha, beta, gamma when you're doing like a triangle, and a lot of times when we're just talking about an angle, they'll use theta. Okay? But there's other ways you can label them as well. Okay, so when we have an angle, let's have an angle like this. There's a starting and a stopping point for the angle. So earlier I drew an angle, but if this is the initial side, then the angle is going from here over, from here over to what we call the terminal side. So it's ending at the terminal side. And so this would be like theta, we might call it, okay? And that angle, they'll usually draw like a line when they're showing that, and they'll kind of make it like in a curve, that angle there is where we're going from this terminal side over to this initial side, okay? I'm sorry, from the, that'll mess us up. It's going from the initial side over to the terminal side. Okay, so initial, start, and then terminal, stop. Okay. So a lot of times we want to talk about the measure of an angle. So the symbol for that is the measure of angle A. Okay, so then here's an angle. And then we're talking, whoops. Let me put arrows on that. So maybe this is angle A. And then we have the terminal side, or the initial side here, and the terminal side over here. Okay? We are going to be measuring in angles sometimes in degree measurements. And we're going to talk about that in this section, but we can have a 30 degree or a 10 degree angle or something like that. Okay? All right. Angles in standard position. Okay, so now here we go. When we have the Cartesian coordinate system, so an axis system, Then we're talking about when we want it in standard position. Let's say we want a 30-degree angle in standard position. Then you're going to put your initial side right here on the x-axis. You're going to put the vertex at the origin. And then if I'm drawing this, I'm just going to try to kind of eyeball it. That's probably a little too big. And say that that represents then 30 degrees like that. Okay? Now, if I want it highly accurate, I need a tool called a protractor. We're going to just be eyeballing these measurements and doing our best on that. So, like I said, that one's probably a little too big. Okay? Probably more like 37 if you got a protractor out or something. Okay. And right now we have a degree measurement. When you have a degree measurement, you're going to need to put the degree symbol. So it's that superscript, a little circle, to signify that it is a degree. Okay? All right. Positive and negative angles. So let me go back to our quadrant system then. So we just had drawn, a 30-degree angle. But what if we had something like a negative 45-degree angle? Well, then you would have the initial side here, and then it's going to be down here. It's going to measure this way, clockwise. So we measure these clockwise when it's negative, okay? So this would be a negative 45-degree angle, okay? So it makes a difference which way we go around, okay? Over here, it's positive. This is a positive angle. And you go counterclockwise. Over here, when it's negative, we're going clockwise. Negative angle. Okay? Now these are in standard position, so the vertex of the angle is going at the origin. The initial side is, it's the positive side of the x-axis, if you want to think of it that way. Okay? All right. So a lot of times we need to be able to put an angle in standard position. So because of this quadrant system we have what are called quadrantal angles. And there's a few things in this first section, I should say in chapter 5, that we really want to pay attention to. So we really have to be familiar with. And every time I say that, just take a note, put a star by it in your notes or something. You need to know what the quadrantal angles are. Okay? So you can have, a ray here, and then let's put one ray right on top of the other. Okay? So it kind of looks thick there. But that would be 0 degrees. You haven't rotated it. Okay? So we didn't rotate the terminal side. And so we do talk about angles that measure 0 degrees, okay? The next quadrantal angle is going to be right here. And so now we have 90 degrees, okay? So that's a quadrantal angle. Now, if I were to go from the initial side here and all the way over, that would be 180 degrees. That would be the next quadrantal angle, okay? All right. And then if I were to go from the initial side over to here, that would be 270 degrees, okay? So you're talking about an angle that's going all that far around, like 3/4 of a circle, if you want to think of it that way. All right, and then finally, you can go all the way around, and that would be 360 degrees, okay? So those are the quadrantal angles. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now notice that when you go back to 360, you've rotated around a full circle and you're back to where you started from, right? Okay. So one complete circle is 360 degrees. Okay? We could talk more about that and the history and how they're used in calendars, and it's close to a year and things like that. But I'll just let you study the history of that on your own. But one full rotation then, one time around the circle, is 360 degrees. Now notice all of these were positive. So you might be asking, well, could you go in the negative direction? Yeah, you could go in the negative, and those would be more, you could have negative 90 degrees and negative 180 and negative 270. But a lot of times they're just going to talk about the positive quadrantal angles, but you could have them as negative. Okay, that's a 0 there, 90 degrees. All right.